Our job is to take a number and split it into its integer part and its fractional part. So here's a number, and we can get the integer part by flooring it. So this symbol is kind of a stylized wall and the floor next to it, so that's floor. And we could also round up using the ceiling, which would be like a wall and a piece of the ceiling above. But now we're flooring, and that gives us 1. Then what we could do is we could subtract this. So we can make a what's called a train, or it's a fork, a special construct where we refer to the function, to the argument in terms of function application. So this is, you could call this a one train, and then we can use the identity function to just give the number itself. And if we subtract the floor from the argument itself, then we get the fractional part. Now all that remains then, because we have to return a 2-element result, which is the integer part and then the fractional part, is to concatenate in front the floored part. So that's the integer part. This is one way we can do it. There are other ways to do it. We have something called the division remainder. So when you divide, if you are using integer math, then you might have something left over. Say, if we divide 10 by 3, we get 3 1/3. However, if we did an integer division, then we would only get up to 3 times 3 is 9, it would have 1 left over. So if we can write that in APL with a vertical bar, which this is a notation taken from traditional mathematics, means divides. So 3 divides 10, then what happened? You get 1 left over. If we had 3 divides 11, then we would get 2 left over. And so here comes the trick. If we have a number that's not a whole number, and we want to divide it by 1, then, well, of course it gives the same result. But if we were using integer math, the closest we could get is the 1, and then we would have this left over. So if we say, what's the division remainder when we divide by 1, then we get the fractional part. And so we could go up here and substitute it. And all we need to do is to take this 1 and bind it together with the remainder function to create a function that just takes a single argument, because we've already filled one slot with the 1. And we can write that as with this jot composition operator. And this says the 1 should always be the left argument to the remainder function, and then we concatenate the float value on the left. So this is another way to do it. But there's actually a very neat way that we can do this in one go without constructing the result from its 2 parts. And that is by using the encode or represent function. Now, let's say that we have a movie which lasts 96 minutes. But we want to know how many hours and how many minutes is this. So what we can say is we use the encode. We could also see this as kind of like a letter T, and it stands for converting to a base, which could be a mixed base. So we have a number system for time where there are 60 minutes in an hour. And then it doesn't really matter how many hours there are in a day. It would be 24, but it doesn't matter in this case. And if we use 0, then we don't roll over to the next unit. We just say this is the highest unit, and anything that's bigger than that will just remain within that position, keep counting up. So we can see this is 1 hour and 36 minutes. Now, what if we were to represent in where the unit is a 1? And then that means that none of the whole part of the number can be represented in this digit. Only anything less than that. Before we go there, let's just try it. 96 and a half minutes in hours and minutes. We can see that the fractional part goes over here. And so if we change this to a 1, then the whole 96 will overflow to the next higher unit, which is the highest one, and the 0 indicates that everything goes there. And we just get the half remaining. And we can try that with our other case. We can see that it splits it up. So a whole solution to this as a full function, we do the same trick as we did with the 1 and the remainder, binding them together using the jot. So too, we can bind together the 0, 1, which is an array, with the encode function, and this becomes a standalone thing that we can give a name, and we can apply it. And that's the entire solution. Thank you for watching.